You can be an NHS in middle school?
That's called NJAH.
Oh, junior honors.
I see.
All right, what are we doing today? Do you look at your little handouts? Okay, so we're gonna pick up on, do you remember we covered like holes and asymptotes and Bobobot and Betsy? Okay, none of that is on your QSA. The QSA is the district test that Richardson makes y'all take. So it'll go in Q2. All of your grades for Q1 are in focus. So the asymptotes and holes homework, that's going to be the start of Q2. So if you're panicking trying to finish those, they're in the next quarter. Everything 1 through 11 is what you need to focus on for the end of Q1. Okay, then today after school is deadline for late work. We'll say like 6-ish, so that I have time to type stuff in, and then I submit tomorrow. Okay. All right, and then if you need help with anything, I'll be here after school. I'd love to help. Okay. All right, so take a look at number 1. We're gonna do the second one. Can you tell me what the negative in the front does? Okay, good. And a lot of y'all put ROXA on your test, and I had no idea what that meant, but I guess that means reflect over x-axis. So I'm gonna put reflect across x-axis, and then I'm gonna put above that the negative, just so that you remember what feature it was that did that. Okay, now let's focus on the number. There's a 0.25. What does that do? Vertical what? Okay, we'll make it multiple choice. Compression or stretch? What does 0.25 do? A stretch or a compression? Compression. Okay, vertical compression. And then above that, I'm going to put the 0.25. Okay, remember, what's the cutoff where it switches from a compression into a stretch? What number? Okay, it's kind of, it's a fraction, but really the cutoff's 1. Anything bigger than 1 is a stretch. Anything less than 1 is a compression. Okay. Then last thing here, we have a -4 and a +2. Those are going to shift the graph. Which way will the -4 move it? Left or right?
Right.
Okay. So right 4. And then what about the +2? Up 2. Okay. So those are rules we've been seeing since Algebra 1. Hopefully we're comfortable with those. Okay, go down to number 2, please. We're going to do parts A and C. Okay, for part A, you want F of G of 3. Another way to write that is F composition G of 3. Okay, and so you should be familiar with both of those notations. But I do think that for your QSA, it's the one I typed, where it's the double parentheses. But remember, the little O is what you'll see on like SAT and ACT and stuff like that. Okay, so what do I do if it's a composition? What do I do with 3 first? Plug it into F or G? G, which is the closer letter, right? So I'm going to put little steps here. Plug X equals 3 into G. Now, can you tell me what the G formula is? Just read it out loud.
X squared.
So now it's 3 squared minus 4, right? Okay, what's 3 squared? 9 minus 4? 5. Okay, then I'm going to take 5 and do what? Now plug it into F. Does that make sense? So you start with that closer letter. We did G first. And now that we have that answer, we're going to plug it into F. So I'm going to write plug X equals 5 into F. Okay. And then what's my F formula? Okay, so now it's 5 plus 1, which is 6 would be your final answer. Okay, notice that 5 is an answer you get along the way, but your final answer is taking that number and then plugging it in. Okay, are we good with that? All right. Most of that on your test went okay, but once we switch to formulas, C is where I saw more people struggling. So let's do this one, please. Okay, it's G of F of X. Then we are going to plug F of X equation into G of X formula. Let's work this out a little bit. So can you tell me what the G formula is? Okay, it's x squared minus 4. Then I'm going to change that to blank squared minus 4. And I'm going to leave that x spot open because I'm going to put F's equation into that position. What is F's equation? X plus 1. Now, if you're plugging into a blank with something happening to it, you need to put parentheses around it. Is something happening to the blank here? Yes, it's being what? Squared, so you have to use parentheses. Okay, but if there's nothing going on around it, like no number in the front, no squared, no subtraction in the front, then you could let the parentheses go. Okay, what do we do with the squared? Write it twice and then multiply it out. So that'd be x plus 1 and x plus 1. Okay, don't forget the minus 4 is still there. And then we're going to multiply that out. Or FOIL if you like that better. So x times x is what? X squared. Then what about x times plus 1? Okay, or 1x. Okay, but same thing. Then 1 times x is another 1x. And then what about 1 times 1? 1. Good. Remember, we're not adding, we're multiplying. Okay, then from there, you're going to combine your like terms. X squared doesn't have anybody to go with. How many final regular x's? Okay, that would be 2 x's. And then what is my constant going to be here at the back? Minus 3. Good. Okay. So you should be fairly comfortable with plugging equations into each other. Okay. All right, for number 3, I don't really want to do this one all the way, but I do want to have you set it up. So if you're dividing by x plus 2, what would you put in the box? Okay, minus 2. And remember, synthetic division is a shortcut for long division. So if you're good at long division, it would take you like a whole page, but you could do that. Okay. So we're putting a -2 in the box. And then from here, I'm going to list out all of my coefficients, but will you look at that carefully and tell me what we need to pay attention to? Yeah, the x's have to count down by what? 1 each time, right? So if there are any skips, what do I put in those positions? A 0. Okay, so I have a skip. I think you had said x3. That's correct. Any other skips? 5 is missing. And then there should be one more. Regular x is also missing. Okay, so it has to go x6, x5, x4, x3, x2. You're not allowed to have all these little skips. Okay, so now let's list our numbers. We're going to start with the 8. Next one's going to be a 0. Next one's going to be a 3. Then another 0. Then a 7. Then another 0. And then a 2. Okay. I'm going to start it off for you just to make sure you remember the pattern. What do I do with that first number? Drop it straight down. And then I take that number and multiply it by what? Whatever's in the box, in this case, a -2. 8 times -2 is, and then you're going to add that column. So if I do 0 plus negative 16, what am I gonna get? Negative 16. Then I'm gonna take negative 16 and do what? Times by negative 2. That's gonna give me positive 32. And then remember you're adding, so 3 plus 32 would be 35. Okay, and then et cetera, et cetera, et cetera. If you want to write down, your remainder should be 590. So the numbers get kind of out of control, but I didn't write the question. Blame RIS. Okay. Then when you do this question on your actual QSA, you're typing in the answer. What did I tell you the remainder is supposed to be? So you're going to put that in the remainder box. Okay, and then the quotient box is where you're going to put your final answer. Okay, this box, as you're typing, is going to keep getting bigger, but on the paper, it's too small. So let me just remind you how to write your remainder. You're going to have all these numbers down here. What power should your quotient start at? 5, because what was the original? X 6. So when you divide an X out, your quotient should always start 1 power less than the original. So for the quotient here, I'm just going to start you off because obviously I didn't finish it. It would be 8x to the 5. Then what's the next front number? Negative 16x to the what? 4. Then plus 35x what? 3. Okay, then you're gonna have blank x squared, blank x, and then one final number by itself. So the quotient's kind of too long to really fit in that box, but when you're typing it, hopefully it won't, you won't struggle to fit it in because the box will go. All good with that? All right, go ahead and turn the page. I'm gonna give you plenty of time to finish this in class today. Okay, so don't feel like you need to finish it right now. Let's do number 4. Okay, number 4, you will have both Desmos and a graphing calculator, but hopefully you don't need that to graph this function. What is the shape of an x squared graph? Okay, I'll give you choices. V, line, U, squiggle. Huh? Line would be a regular x. What if it's squared? The U or a parabola, right? Now, which way am I going to shift it with the plus 3? To the left 3. So we'll go left 3 and then down 1, right? So go left 3, down 1. Okay, and then I want you to place your dots. Remember, for the parabola, you're going to go over up 1, over up 3. Okay, over up 1, over up 3. Over up 1, over up 3. Do not connect your dots. Just draw them for now. That would be if I wanted the entire parabola. Okay, so I'm going to connect it in yellow, but this is not going to be your whole graph. Okay, why do I not want the whole parabola? What does it say after the equation for x is where? What, honey? Oh, my child. Oh, okay, bye. Okay, for x is where? What does that say? To the right of what number? -3. So -3 is here. Then I'm only going to connect this dot through these points. And all of that left half of the parabola doesn't end up being included in my final graph. Okay, so I'm going to put right here. This means that I want the right side only. Okay. All right, so part A says to graph on the grid to the right. We did that, so I'm just going to put a little check. Okay, then it says f of x is increasing, true or false. Now remember, we're not looking at the whole parabola because the whole thing's not increasing. How would it start out here? Increasing or decreasing? Okay, but then right here it starts what? So is it increasing? Is that true? Yes. And if you want to write for yourself, you get to use this on your QSA. Okay, increasing means uphill, think like the roller coaster, but you have to start on the left side and then work your way to the right. Okay, next one says I have an x-intercept at 4, 0. True or false?
False.
4, 0 is way over here, so that is false. Okay, next one says graph f -1 on the right. What does that mean? Inverse, very good. And how do I find an inverse? What do I do with the original points? Flip them. So I'm gonna make a little mini chart. Notice we only have 3 points. That's fine, because we can't use the other ones over here. I'm gonna label this graph f of x. So this point was -3, -1. What's the next point right here? -2, 0. And then this would be -1, 3. And then remember to go to the inverse, you're just swapping the order. Okay, so let's put f to the -1 here. We know that means inverse. I'm actually gonna write that above it, inverse. So what will my first point be? -1, -3, good job, Anaya. Okay, next ordered pair, what'll it be? 0, -2. That would be here. And then we need that last one was a -1, 3, now it's a 3, -1. Like that. Okay, and then I'm gonna draw my graph. Okay, also, if you want to draw in your line of symmetry, where should both sides of your graph match each other? X-axis, y-axis, or diagonal? Diagonal. So right here, that should be your line of symmetry. And so if you kind of look at it here, you can see that these match. But notice that if I had taken the whole parabola, then they wouldn't match each other, right? That's why this part is excluded from the graph. Okay, now we're answering questions about F inverse. Okay, it says the original F was increasing, but the inverse is decreasing. True or false? What is that doing? That's increasing, that is false. Okay, and then it says I have an x-intercept at 4, 0, true or false? Okay, it's at least not a pretty point, right? Or else we would have graphed it, so I'm gonna put false. It is probably close to 4, 0, but it's not. Okay, and then last one says to find the algebraic inverse. How do I start off finding, algebraic just means like the equation. So how do I start that out? Take x and y in the equation and do what? You're gonna switch them. So switch x and y, solve for y equals. Okay. So I'm gonna set that one up for you, but I'm gonna let you do it on your own in a couple minutes. Okay. So if my original equation was an x plus 3 squared, now it's a y plus 3 squared minus 1. And then instead of my y equals being at the front, I'm gonna let it be an equals x at the back. Okay. And then I'll give you some time to do that here in a second. Any questions on that? Okay, I want you to put a star next to number 5. Okay, for the QSA, one of the equations they asked you to find the inverse is a fraction. And we haven't covered that. Okay, but it's the same process. It's just gonna involve a little bit more algebra. So we're gonna do this one, and then you're gonna get to practice on this one. Okay, but this is the type of inverse that they have you doing on the QSA. So as we're going through it, we're gonna write down steps. Remember, you get to use this, so don't sweat it. What's the first thing I do to find an inverse with the letters? I switch them, right? So instead of x over 3x minus 7, now it's gonna be what? Y over 3y minus 7, right? So let's start off by switching our letters. So it's y over 3y minus 7 equals x. That's step one. That's always been step one. The only reason this equation is a little worse is because how many y's am I dealing with? There's 2 if it's a fraction. So the first thing I want you to do is cross multiply. Now you'll notice that x doesn't have anything on bottom, so we're going to just put that over 1 and cross multiply. Okay, so let's do this diagonal first. What is 1 times y? 1y. And then for the other diagonal, I'm going to do 3y minus 7 times x. So I'm going to do x times 3y minus 7. What am I missing? Oh no. What happened? It is parentheses. Did that just switch? Okay. And then what did I say I was missing? Parentheses, because it's not just x times the 3y, it needs to be times the whole thing. So put parentheses there. Okay, eventually we need to get our y's onto the same side. Okay, but I can't do that if those parentheses are there. So let's distribute the x. What is x times 3y? 3. I'm going to put xy, but it's the same thing. So 3xy. And then what about the x times the minus 7? Plus or minus? Okay, so minus 7. Okay, then from here, whichever term has a y in it, I want to get it over to the same side with the other y. So if I have a 3xy and it's positive, how can I bring it across to be with the 1y? Keep in mind, this is a positive right now. Subtract. So I'm going to minus 3xy and minus 3xy. So I have 1y minus 3xy, these cross out, equals negative 7x. Any questions to there so far? It's next class. Okay, then from there, what do both of those y's, I just gave the answer, but what do both of those terms have? They both have the same letter y, right? So I can take the y out. You want to write, we're gonna GCF and divide the y out. What would be left over in the parentheses? So I had a 1y, but I took the y out. What's left there? Just a 1. And then what about from the minus 3xy? What's left? Just a 3x. Okay, and now do you see that your y and your other crap is separated, that we're just down to 1y? Then now we can get it by itself. If these are multiplied, how do I get rid of this? Divide. So if it's y times the parentheses and I want to get rid of the parentheses, I'm going to divide by it. So I'm going to do 1 minus 3x on bottom, 1 minus 3x on bottom. And that would be your answer. Okay. So it'd be y equals 7x over 1 minus 3x. Okay. And if you want to go back and make any notes on that, just so that when you're taking a QSA, you'll remember what we did. Okay, but then I wrote another question right next to it for you to try on your own. Okay, any questions so far? Okay, we're going to do one more question together and then we're going to take a little break. Number 6, let's do letter B. So you have a polynomial graph on the left. Okay, and then I want you to write here on your actual QSA, it's not going to give you the graph. Okay, but remember, you can use Desmos. Or if you like this guy, do it on here. Okay, but they're going to give you an equation and you would have to look the graph up yourself. So I'm going to put use Desmos or calculator to graph. Okay, they might give you the graph on some of the equations. But if they don't, just put it in Desmos or put it in here. Okay, so we have the graph right there. It says, identify where f of x equals 0. Okay, f of x is gonna equal 0 at all of the x-axis points. So do you see any? How many are there? 3. There, so I'm gonna put here x-intercepts. Okay, there are 3. Tell me the first one, please. Okay, -4. Next one. 0 right in the middle. And then last one. 5. Very good. Okay, so you would put -4, 0, and 5. Those are the x-intercepts. They would make the equation equal 0. Okay, then it says, we covered this only, I think, once. But if you want where f of x is greater than 0, you want it to be in the positives. And the positives are everywhere above the x-axis. Okay. So if it says you want f of x, that's the equation you're talking about, to equal 0. Or I'm sorry, to be greater than 0, you want it to be in the positive part of the graph. So let's shade in where that happens. Is it positive here?
No.
What would that be? Negative, because it's below. Okay, but is it positive here? Yes. And notice that's not the same as increasing means uphill. Positive just means that you're in the positive numbers. Okay. What would I label that interval to be between what two numbers? Okay, -4 until 0. And then I have one more little section of the graph in the positives. It starts at what number? I'm negative here until 5, and then 5 until infinity. That would be 5 till. Okay. Now, peek ahead. We're not going to do it, but for part C, are they asking for the above? No. What are they wanting for this question? If they want less than 0, that means the graph needs to be where? Okay, in the negatives, which would mean below. Okay. I'm not going to tell you which one's on your QSA, but one of those two is on there. So you would just pull up the graph, look for the sections in the appropriate part. Okay, then it says, let's continue, label the end behaviors on the graph. And then is it even or odd? Can you tell me if this graph is even or odd here? Odd is correct. How do we know that? Okay, very good. So ends go opposite ways. Now, if it starts low and ends high, do you remember if it's a positive or a negative coefficient? Which one? Positive is correct. Good job. So I'm going to put here start low and end high means it's a positive coefficient. So not only is it odd, but it's a positive odd. Versus how would a negative odd go? It start at the top and eventually it end up at the bottom. Okay. All right, so then end behavior is where you do the little as x approaches thing. So if I want to do the right end, what would x be approaching if I'm going this way? Would I be approaching infinity or negative infinity? Infinity. And then if that end is pointing up, what should my y be doing? Going towards infinity or negative infinity? But if it's pointed up, then we would want infinity. Okay, then if I want to talk about the left end of the graph, that would be this way. What would I have my x approaching? X is going to negative infinity. And what is y doing if that end is pointed down? Negative infinity as well. Okay. So remember, X approaching tells you which end you're looking at. Y approaching tells you if it's going up or down. Okay, do we feel like we can kind of go back and do some of those on our own? Okay. All right, so I'm gonna give you some time to work. Try to catch up all the way to where number 6 is done, and then in a couple minutes, we'll keep working, starting with number 8. Okay, but ask me if you need any help. Yes, yes. Pass is right there by the pencil. Okay, it's okay if you're not finished, but just so that after lunch, we're kind of like done with our questions we're gonna do together. Will you turn the page, please? So we're gonna do number 9. Okay, so it says, write a polynomial of degree 4. Is it even or odd then? If it's a 4th degree, that'll be even because 4 is an even number, right? Okay, so I'm just gonna put, I know it needs to be even. Okay, that has roots at 2 and -5. Now remember, roots and x-intercepts are the same thing. So if I want to have an x-intercept at x equals 2, what would the parentheses have said?
X minus 2.
X minus 2. What if I want to have another x-intercept at x equals -5? That would be x plus 5. Now notice that it says those are singular roots. Remember, a singular root means that it's going to pass at the x-axis. Okay, then it says, read this last part carefully, we're going to have another root, multiplicity of 2 at x equals -3. What is the parentheses going to say if it's x equals -3? X plus 3, and a multiplicity of 2 means that it's a double root. How do I show that it's a double in the equation? Squared, very good. And do we remember what happens on the graph if it's a squared? It should be a bounce, very good. Okay, so then it says to sketch the graph, let's do it. We're gonna put x-intercepts at what numbers? +2, -5, and -3. So 1, 2, 3, 4, 5. 1, 2, 3, and 1, 2. Then I'm also gonna label which type each one is. Which ones were my singular roots that should pass? Okay, so this is a pass, and this is a pass. And then how did I know that the 3 was the bounce? Because it has what on it? Squared. Now, we said that this is an even degree. Do the ends need to go together or opposite? Together. So let's start at the top. Ready? I'm gonna pass. Then I'm gonna bounce. And then I'm gonna pass. Now keep in mind, you get Desmos, you get a calculator. You can graph it in as many spots as you want to, okay, but you should understand the connection between the equation and the graph a little bit, okay? All right, number 10, put a little star by this one. Okay, it says if x equals 5 is the solution for the equation equal to 0. Give me 3 other statements. Here's what that means. If 5 is an answer to the equation equals to 0, where is it going to be on the graph? If it makes it equal 0. It's gonna be an x-intercept. Okay, because remember, that's what the equal 0 means, is that you're looking for x-intercepts. Okay? So if x equals 5 is a solution to that, that means it's also an x-intercept. Another way of saying that is that it is a real root. Now, let's talk about why is it a real root? Because 5 is a real number. How would it not be real anymore if it had what letter? An I. If it's 5i, then it's not a real root anymore. But if it's just a 5, that counts as a real root or a real 0. Okay, last thing, if x equals 5 is the answer, what would the factor be? Remember, factor means parentheses. Yes, minus 5. Okay, so if 5 is the solution, then it's where it crosses the x-axis. It would be called a real root, not an imaginary, and it would be x minus 5 for the parentheses. Make sense? Okay. Then I had really hoped to finish this last little page here. For 11, you're just gonna graph those and look for the domain. Can you do that without help? Okay, so I'm gonna put for the domain here, graph in Desmos. Hey, I don't expect you to know what those graphs look like, but just graph it in Desmos, kind of look at the picture, and then domain remembers how far it reaches to the sides. So hopefully you can do that without help. Last one we're doing together is number 12. Number 12, it says find all roots, not real roots. Real roots you can find using a t-chart. Okay, but if it's any kind of root, it could be an I. That means we're going to go quadratic formula right at the top here. You do not have to memorize the quadratic formula. It will be provided for you when you do your test. We're going to do letter B. Okay, so I'm always going to set up the formula just with the numbers missing. Then I'll plug them in a second. So the first number I want is negative B. B goes in the first two blanks. What is my B in my equation? What number? Okay, negative 90 is correct. So this is A, B, C. So I'm going to put a negative 90 here and here. Next one I want is AC. My A is a what? 25, and my C is an 82. And then on the bottom, I want another 2A, which would be a 25. What part of that do you put in the calculator? The part under the square root. Should you also put the square root? No, because if it's negative, it's going to give you an error. So go ahead and type that in for me, please. What are we getting for that number? Negative 100 is correct. Very good. Okay, then in the front, I had a negative 90. What's that? Okay, that's really a positive 90. And then on the bottom, I have a 2 times 25. What's that? 50. Okay, the square root of 100 I can do. Ashley, is that for me? You can do it. Just put it right there. Thank you. And then what's the square root of negative 100 though? Gonna have a letter in it. Thank you. 10i. So it'd be 90 plus or minus 10i over 50. And then what's your last step on that? If all the numbers can reduce, what can they all reduce by? 10. So then I would say, okay, these can all divide by 10. So it'd be x equals 90 divided by 10 is now 9. 10i divided by 10 is now what? 1i. I'm not gonna put the 1, but you could. And then 50 divided by 10 would be 5. Now, on your QSA, I'm not sure if they'll give you a plus or minus button. So if they don't, remember, you just type them in separately, so it'll look like this. If no plus or minus, you do 9 plus I over 5 and 9 minus I over 5. Okay, and notice that it's the same thing. Hopefully they give you a plus minus button, but if they don't, you would just type them into the boxes separately. Okay. All right. Then these questions right here, plus and minus go together. So if you know 5 minus 3i is a root, what would the other half of that root be? 5 plus 3i. Okay, remember, they're always going to come in plus minus partners. So if 5 minus 3i is a partner, the other partner would be 5 plus 3i. If it's a -7 plus 2i, what would the other partner be? -7 minus 2i. Remember, the plus minus should be in the middle. Okay? All right, you have the whole rest of time after lunch to finish that up. Enjoy your lunch.